All right. I'd like to talk about a somewhat interesting thing that comes up from time to time. There's a function called the gamma function, and there's a kind of neat proof of the gamma function and how it relates to factorials. So I'd like to do that now. The gamma function is a function that takes what are called complex arguments. And what it will do is it will take in complex arguments and it'll spit out some number. And this is how you obtain the number. It's a improper integral of 0 to infinity. It's x to the z minus 1 e to the negative x dx. So that's what a gamma function looks like. A kind of interesting thing is that if I feed in the value of n, right, so any non-zero or any positive integer n, right, it appears that the gamma function returns n minus 1 factorial. So that's kind of cool. So let's see if we can prove it using induction. Right, so proof. Right, the proof is by induction. So I start out with my basis. Right, if it's for all non-zero, or let's say for all positive integers, right, the basis is going to be that p of 1 is true. Right, basis p of 1 is true. How do I show that? Well, I want to start with the left-hand side. That's gamma of 1. So that's an improper integral from 0 to infinity. If I put 1 in there, I get x to the 1 minus 1, which is x to the 0, e to the negative x dx. So that just gives me this integral. That's 1 times e to the negative x, so that's just e to the negative x times dx. And if I were to do this, I won't use the limit stuff in here because I won't. What I'll find is that I'm basically evaluating negative e to the negative x at the points from the point 0 and infinity. I can't technically evaluate this at infinity because, but it is going to tend to 0. So what I'll get is it's 0 minus, in this case, a negative 1. That gives me just a positive 1, right? But what's on the right-hand side? Right, that was my left-hand side. The right-hand side is going to be that's 1 minus 1 factorial, which is 0 factorial, which is just equal 1. Right? So the left-hand side is equal to the right-hand side. Right? That means that p of 1 is true. Now comes the inductive, right? Did basis, now inductive step. Right, remember I suppose that p of k is true. Right, that is, right, I'm going to suppose gamma k is equal to k minus 1 factorial. And what I want to show is that the gamma of k plus 1 is going to give me k factorial. So let's see if we can actually get that. Let's see if we can actually get this to work. Right? So Take for instance, right? Well, what is gamma of k plus 1? Well, I know by the definition of the gamma function, it's an improper integral from 0 to infinity. X to the k plus 1 minus 1 is just going to give me x to the k. And then from here, what am I going to get? Oh, goodness. From here, what am I going to get? Well, I'm going to get just e to the negative x and then dx. So, there's a little trick that people use for evaluating sometimes very strange looking integrals where there's multiplication, and especially when exponents show up. We're going to use something called integration by parts. So notice if I do that, what I'm going to get is negative x to the k, e to the negative x, plus I'm going to get an integral from 0 to infinity of k x to the k minus 1, e to the negative x, dx. Right. Oh, I guess I should say this is evaluated from 0 to infinity. So what's going to happen, this term is going to go to 0. I'm going to be out, so I get 0 plus this junk over here. Let's take a closer look at what I have. Notice here I've got k, right? Because k is not dependent on any of the stuff inside the integrand, really. So I can pull it out, and I get k 0 infinity of x to the k minus 1 e to the negative x dx. But what do I know about this? Well, this is really just gamma of k, right? I know that this is k times gamma k. What do I know that the gamma of k is equal to? I know that this is k times, right, k minus 1 factorial. And if you know how the factorial works, this is actually equal to k factorial, because k times k minus 1 factorial is in fact k factorial. Right? So there we go, a proof that right now it's done. Right? A proof that if I pass in any positive whole number into the gamma function, I'll actually get that number minus 1 factorial. An interesting side note.